The third way that you can solve a system of equations is with what's called elimination, all right? So if you've already learned graphing and substitution, you can also do it with what's known as elimination. This one works best when you have kind of two equations written in what's called standard form, right? The x and y are on the same side. And what we want to try to do is eliminate one of those variables, hence the name, okay? So this is an easy one. We're going to kind of work our way up as in terms of difficulty, kind of start easy and work our way towards harder ones. This one's easy because these are going to combine these two equations. You notice right away that we have a positive 3y and a negative 3y. So if I treat this as one sort of big addition problem, those would cancel, right? Or they would eliminate. And that would give us 6x, if I add these together, right? X plus 5x is 6x. That's eliminated. So I can say equals on this side 24. Then we can solve for x, and then we can take what that is, plug it back in, and get our ordered pair for our answer. If I divide both sides by 6, this is going to give me x equals 4. So that's going to be one side of my ordered pair. Now, you can take whichever one is easiest. I like to just kind of look and see, probably the top one there is the easiest one to plug this back into. And if I take the top, it says x plus 3y equals negative 2. So I would sub the x in right there. So it's going to be now 4 plus 3y equals negative 2. If I subtract 4, let's see, this is going to give me 3y equals negative 6, divide by 3, and y equals a negative 2. So my answer written as an ordered pair, an xy ordered pair, x is 4, y is negative 2, and that's the answer to this one. Let's try one that's a little bit harder. All right, like I said, this one's a little bit harder because if you look at it, there's nothing that's going to eliminate right away. We would need one number to be the same and one to be positive and one to be negative. Here, that's not happening. What we could maybe manipulate this bottom one so that it would eliminate. What I mean by that is here, this was a positive 4x. I would need this to be a negative 4x. So what I can do is take it times negative 4, but I can't just do it to this one term. I have to do it to the entire problem so that the equal sign is still true, right? So I'm going to multiply, you might say, times all of it on the bottom, and I'm going to distribute this negative 4 in. This is going to give me a negative 4x minus 20y equals, what is that? Negative 4 times 39 is negative 156. Okay, now I like to have mine right next to each other, so I'm going to take this top one and just copy it down. 4x minus 3y equals negative 28. And the reason for that is because now I can clearly see that we have a negative 4x and a positive 4x, so my x terms are going to be the ones that cancel. All right, the rest I'm just going to kind of put together. So this is now negative 23y equals, on that side, negative 156 minus 28 is negative 184. Okay, I'm guessing negative 23 probably goes into that. So let's try it. If I divide by negative 23, divide by negative 23, what do we get? We have negative 184 divided by negative 23 is a positive 8. All right, so my y value is going to be 8. Now you can take that and sub it back into whichever one of these two pink ones that you want. Try to maybe find the easiest so you can save some time. Probably this bottom one, I would say, is easier. Doesn't matter though. This says x plus 5y, just rewriting it, equals 39. And I'm going to replace my y right there with 8. So now it's going to be x plus 5 times not y anymore, but times 8, because I just found it, equals 39. If I do the math, this says x plus 40 equals 39. Subtract 40, and we get x equals a negative 1. So the answer to this system of equations by elimination is going to be the ordered pair, negative 1, right, the x first, and your y value of 8, negative 1, 8. All right, let's try an even harder one yet. All right, so this one has some fractions in it, but don't let that scare you too much because the y terms here don't. And I think we can maybe manipulate these in such a way where those will be the ones that can eliminate. All right, so for example, I need one to be positive and one to be negative, so we can just multiply by negative to take care of that. And then think about 4 and 6. If I think of about 4, if I multiply 4, 8, 12, 16, you know, if I can have the multiples of those. 6, its multiples are 6, 12, 18, and so on. 12 is one that they share. So for example, in order to get this top one to become a 12, I can multiply it by 3. In order to get this bottom one to become a 12, I can multiply it by 2. Right now, like I said, if I do this just how it is, this would be negative 12 and this would be a negative 12. I need one of them to be positive so that they will eliminate. It doesn't really matter. You can choose whichever one you want. I'll just make the top one negative. If I multiply this in, this is now going to be on the top negative 3x, positive 12y, right? And then negative 45. And this bottom one, if I multiply it, when you multiply by fractions, here we're multiplying by 2, and this fraction means what we're dividing by 2. So the 2's essentially going to cancel, leaving me with just 3x. Okay, over here, 2 times negative 6y is negative 12y. Remember, we chose that for that specific reason, so those would be the ones that eliminate. And then lastly, same thing with the 2's over there. The 2 and 2 are going to cancel, leave me with just a negative 1 on that other side. Now, this one is a little bit special because both the y's and the x's are going to eliminate, giving me 0 left on this left side. On the right side, I have a negative 46. And we have to decide, is this true or false? And of course, that is false. 0 does not equal negative 46. So because of that, it has no solution. All right, the last one we're going to do is also another one where we're probably going to have to manipulate both of our equations in order for this to work out, okay? Because if you think about the x's, I like to start with a smaller one. If I just take its multiples, 2, 4, 6, 8, I skip right over 5. And same thing with the 3's, 3, 6, 9, 12, I skip right over 7. All right, so we're going to have to manipulate both. And probably the easiest one is the x's. And sometimes if the numbers are small enough, you can just multiply by their opposites. What I mean by that is, in this top one, since I need to get this probably to be 10, I can take it times 2, which is down here. And this one I can multiply by 5 to also get me to be a 10. Now, again, like that last one, they're currently both positive, and so I need to make one of those negative so that they will eliminate. And I'll just do the top one. All right, if I multiply through, let's see what happens. Here it's going to be a negative 10x, a negative 14y, equals negative 18. All right, and then in the bottom one, this is going to be a positive 10x, which is good. That's going to eliminate. And then a negative 15y. And lastly, I don't know what that is, 5 times negative 37 is negative 185. Okay, so let's treat this like a big addition problem and add those together where the x's eliminate. One's positive, one's negative. This is going to be negative 29. Y, and what is that? Minus 18. That is negative 203. Okay, I guess that's going to divide into that nicely. Divide by negative 29. And does it? Divide by negative 29. Yes, it equals 7. So we'll say y equals 7. Now, just like the last few, we do have to plug this back into one of the ones in pink. You can choose whichever one's easiest. To me, they look kind of equally hard. Maybe I'll try the bottom one. If you want to try the top, go for it. See if you get the same thing that I do. It's 3y equals negative 37. And so I rewrote that bottom one. I'm going to sub this in for the y right there. And let's see if it works. Let's see, 2x, don't need parentheses, 2x minus 3 times, this is where I need the parentheses, equals negative 37. I need parentheses there because I'm subbing in 7. Okay, do some multiplication. 2x minus 21 equals negative 37. It's an ugly looking 3. And add 21 to the other side. And what's this give me? 2x equals 16, negative 16. Divide by 2, so x equals a negative 8. All right, again, remember, you write your answers as an ordered pair. Don't leave it like this. And your ordered pair for this one, the x is negative 8, and your y is 7. All right, so that is how you solve system of equations using elimination.